Hi, sir. Good morning.
Hi Riyanka.
Yeah, hi, sir.
Hmm. She's also wake up now only, huh? Hmm.
Yeah, I think
Yeah.
I should have called.
Right.
Oh, yes.
Yeah, number system conversions, all these things. From combinational circuits you want to join, right?
Yes. Only
Okay.
combinational circuits. That to add a subtractor, I know.
Ah,
Uh, I need the sequential part.
okay.
Combinational also. What else do we have, sir, apart from adder subtractor?
Ripple carry adder, ripple
Yes,
carry
sir.
adder.
Look ahead.
Uh,
Carry adder.
carry look ahead adder, right? Hmm.
Yes.
Okay. So then parallel ladder, both are same. Parallel ladder subtractor, it will be added together. Okay.
Okay.
Then what else? Combinational circuits related to decoder, encoder, comparator, and then
That
uh,
part
mu-
I want, sir. Encoder,
uh,
decoder. That. From there I
multiplexer,
want. Yeah.
multiplexer, demultiplexer. So that's what.
Yes.
And
Okay.
then some programmable logic devices, PLA, PLD, PLA, PAL, and PLDs.
That is also completed, sir.
That is also completed. I have posted that.
Okay.
So just for knowing purpose, I have explained that PAL and PLA and PROM. Okay.
Sir,
So,
any interview question in combinational circuits will they ask, sir?
this type of questions, can you explain me 4 by 1 marks by using 2 by 1 marks?
Oh, okay.
Okay. This type of questions they will ask.
Okay.
Okay, sir.
Hmm. So,
So in the
or,
video batch, whenever you start with this, please let me know. I will
hmm.
attend over there. The combinational.
Okay,
From
okay,
combinational, yeah.
okay, okay.
Yes. So these are all theoretical, right? You will again take it
Hmm.
on the PA playground as well. So that time
Hmm.
also if you explain that is fine.
Okay, okay.
Yeah. So instead of doing theoretical, can't we do like
Hmm.
marks once you teach, then we can do it on EDA playground, so it will be completely clear.
Hmm. Yeah. Okay, fine. So, what is the difference between the combinational and sequential? So, these are the topics we want to learn. Flip-flops and binary counters, 3-bit triple counters, synchronous counter, registers, and shift registers. Okay. So, these are the topics. I think FSMs are not updated here. What is the difference between the sequential and combinational circuits? So, combinational means we are getting the output immediately. Whenever we are giving the input, the output will be getting immediately. But sequential circuits are not like that. Sequential circuits are depends upon the present input as well as previous output. Okay, so the previous output is giving like a feedback format, so that feedback format will be acts like a memory element. Okay, so this memory element is giving to the combinational circuit and then it will be storing some value. Okay, so then sequential circuit is a collection of memory elements, right? So collection of memory element as well as combinational circuit, so that feedback we are giving through memory elements. Okay, so whenever we are giving the input, we will get the output, and then this sequential circuit is also depends upon the input as well as the memory element. Yeah, tell me any doubt from this?
So yes, sir. I have one
Hmm.
question here with
Hmm.
respect to carry lookalike adder or ripple carry adder.
Okay.
There also we are taking the carry of the previous adder and giving it to
Yeah.
the next adder, right? In
Yes.
case if we are
Yes.
using the other. So that also
Hmm.
is a sequential, or what is the difference between that circuit and this circuit, sir?
No, carry means suppose ripple carry adder you're adding means suppose 5 and 7 I'm adding, right? So 5 and 7 I'm adding means 5 plus 7 means what is the value? 12, right? So then
Yes.
units place is 2 and then tens place is 1. This 10, suppose 55 and 77 you are adding means then 1 where we are adding? Here, right? So same way, this will be acts like a carry, okay, not the feedback element. So it is forwarding that. It is forwarding to the next element because units place we are adding here and tens place it is moved to the next position. So like that only. Suppose 1 plus 1 you are adding means 0 we will get here and then 1 will be going to the next one because we are adding like this 1, 2, 4, 8 in this way we will add the numbers. So this is the LSB bit and this is the next MSB bit. Okay. So then this bit is sum is added here and then carry will be going to the next value. Okay, so then that should be the
Oh,
forwarding the carry element when we are adding the two numbers. Okay.
uh, okay, sir. So that means we
Mm.
are not storing the carry
Yeah,
anywhere. Is it?
yeah, not storing the carry, just adding the next value. Okay, that carry will be added to the next value, and then it gives the response.
So won't the carry will be stored in memory elements here in sequential circuits? This diagram.
So then we will that is the addition and subtractions will not be comes under the sequential circuits. So that will
Okay.
be the combinational circuits only. So whenever suppose I am designing a one flip flop or latch, okay, by using NOR gates. Okay, this is my NOR gate and this is the NOR gate. Okay, so then here I'm giving the two inputs like R and S, reset and set condition. Okay, so this is the output I'm getting, that is the present state output, and this is the next state output. Q bar is the next state output. So I will be assuming that this Q value will be 0. Okay, so then this will be this output single input we can't get the output, right? So then this will be connected to here. Okay, so then feedback I am giving that. So it is depends upon the present input and also previous output. Okay, so then it is giving to this one value. So what is the value we will get here? 0 I am giving here. Suppose R equal to 0, S equal to 1 I am giving. So R equal to 0, S equal to 1. That means some set condition I am taking that. So during that set condition, what is the value of this one? 1, 0 plus 1, 1. Okay. So then this 1 is going here. 1 plus 0. So 0. Okay. Sorry. 0 plus 1, 1. 1 bar is 0. Okay. So in this way, we are getting the output. So depends upon the present state input, we will defines the next state output.
Okay. Yes,
Hmm.
sir. Just I understood. Just I wanted to
Hmm.
ask whether that
Huh.
why the triple carry adder is not considered as sequential circuit,
Huh.
because
Sequential
carry
circuit
also
means.
we are adding.
Hmm.
I mean, part
Yeah.
of output we are adding to the next.
Hmm. Part of the output, but there is no storing element in that. So just forwarding the value. So because we are
Okay.
yeah, we are connecting to that some adder like this. So what is the adder circuit? So this is the exclusive OR gate, and then this is the AND gate. So how we are connecting this? A B will be connected here. See here, I'm not depending upon any this output is connected to input not like this. So if you got the output only, then only this next output we are getting, but this type of thing is not there in this adder. If you give the values 0 1 and I'm getting the output immediately. Okay, so without any further delay I'm getting the output. So this output I'm getting the sum value as well as carry also immediately I'm getting that. Okay, some value is 0, sorry, some value is 1, carry value will be 0. Again, I'm
But
giving to
yes, but
another.
again, if the sum was given to the input, then it would have
Ha.
been sequential.
Hmm. No, no. See, uh, see, forwarding the value means not a sequential. Feedback is needed. Okay. Output to input, that is the sequential. Okay. So output to the next circuit input means that is not a sequential. Okay.
Yes, sir,
So
but sum
yeah,
of the first adder. Here you have given this XOR, right?
yeah,
If
yeah.
I take that sum and give it
Huh.
as input again, will it become
In
sequential?
but input to the next circuit we are giving, not input to the same circuit, right?
No, no, I'm asking in case if we give it to the same circuit, then
Huh.
will it be considered sequential?
No, no, not considered. Suppose, yeah, suppose you are giving the in output, so you are getting the output. So that output we are giving to the previous same circuit input, then it will be considered as a sequential circuit.
Okay, okay,
Huh. So your forwarding to the next circuit means that is not comes under the sequential circuit, because
oh,
one step is over, my output is over, then the next output is giving my output is giving to the next input. Okay, so for that, if we are using two half adders, okay, two half adders we are using, right? So that is the reason we are using this. So
yes,
we are
got it.
connect, yeah, we are connecting that. But here I'm not connecting the output to input of same circuit. Okay.
Hmm. Okay.
If you connect the output of the some circuit and then connect it to the input means it will be treated as a feedback, because I'm whatever I'm giving knowledge, okay, I'm sharing with you. So I'm not asking anything means, so then feedback is not giving. I'm a combinational circuit. Suppose I'm asking the feedback from you means, so then I will store the feedback. So then I am acting like a sequential circuit. Otherwise, I'm forwarding the input. Okay, I'm delivering some output. That output is stored with you, and then you are forwarding to the next circuit, and then you also not expecting any feedback from there. So then you and me acts as a combination circuits. Okay.
Okay, sir. So yeah,
Uh,
with that one bit half adder, like just
uh,
half adder example, I understood. Like if that
uh,
Z and C is there, so if Z
uh,
is connected again to
hmm,
input X or Y,
hmm,
then
yeah,
that will be sequential.
sequence
Otherwise, only forwarding, it doesn't
forwarding.
mean
Yeah, yeah.
combinational only.
Yes, yes. So
Okay.
here, the out present input as well as that output is connected to input. Okay. So output is connected to input, then it will be acts like a memory element. So because here I am having the feedback, that feedback is connected to the combinational circuit. So that is the reason it will be acts like a sequential circuit, because it has the capability to store some value.
Yes, got it, sir.
Hmm. So that is the sequential circuits. In this sequential, we have two types of circuits: synchronous and asynchronous sequential circuits. So suppose in binary information, one memory element is there means, so that will be acts like a sequential circuit. But here, the memory element will be stored is like that. That is the state of sequential circuit. Okay, so if we are giving the memory content element will be present input, then it will be taking as a present state. Okay, and then we are getting the memory element from the referred one. Okay, whatever the referred one means, that output will be coming back to the input, then it will be taking as a next state. Okay, so present state input and then next state output we are having, right? So the present state input is nothing but whatever the input we are giving, that will be the present state. Okay. So what we are referring from that, that will be treated as a next state. Okay. And then here we have,
So here,
yeah,
can you repeat that part? Present state and next state?
present state and next state. Suppose you are giving the value from this input, right? So this will be storing here. Okay, this is my input. Okay, whatever the input we are taking that, so information is storing in this will be treated as a present state. Okay, so then we are getting the output from the memory element. Okay, so this memory element will be treated as a next state. Okay, so we are referring from that. Where we are referring means the output from in so whatever the output you got, that will be stored through memory element and given to combinational circuit. So this is the present state and this is the next state. Okay.
Okay, okay.
uh, every time we are getting the new element from the memory, so that will be treated as a next state. Okay, so then the next value you got means that will be treated as a present state. Okay, present state and next state. See, suppose I'm giving the value like 0 in the current state. Okay, then you are getting some output. That output is again given back to input. This is the next state. Okay, new value we are getting. That new value we are getting means that is the next state of. Okay, so that is the
Okay.
reason combinational circuit is depends upon the present state as well as the next state. Okay, and here the clock is used. So based on the clock only we are saying that the sequential circuits are depends upon the synchronous and synchronous. Okay, synchronous means uh, every time we are giving the individual clock, and then asynchronous means, so I will explain here. Okay, asynchronous sequential circuits. Asynchronous sequential circuits, how we are calling the asynchronous means, so the behavior depends upon the sequence of which we are applying that input. Whatever the input we are applying that. Okay, so based on that the behavior will be depending on that. Okay, here once we are applying the clock, and then next output we are giving as an input. Okay, so the clock is giving like a serial input. So that is the reason we are calling as a asynchronous circuits. See how we are giving the clock means. So first we are giving the clock here. Okay, so then I'm applying the input. So this D flip flop I'm getting the output. So this output will be giving as a clock of the next input. Okay, next circuit. So that is the reason we will call as a asynchronous circuit. Okay, so in this asynchronous circuit the clock will not be placed, the output will be act as a clock. Okay, but synchronous circuits are not like that. Synchronous means same circuit we are having, each and every circuit we are giving the clock like a train. Okay, train of clock pulses we are giving like this. Okay, this will be clock, this will be the clock, and this is the clock, and the next circuit we are taking means this is also clock. So in synchronous sequential circuits, whatever the elements we are giving, each and every time we are giving the clock elements. Okay, so but asynchronous circuit, one output we are getting, that the next output, that output is connected like a clock to the next input, next circuit.
Okay,
Yeah.
so in this circuit which is shown, so
Mm.
this x and small y, so y
Mm.
is nothing but we are considering as clock
Ha.
example.
So this Y will be considered as a clock. So because this Y will be connected to the next circuit, so then it will be acts like a clock.
That itself is acting as delay, no? So the output we are giving it to the delay
Ah,
circuit, and the
yeah.
small one will be acting as clock.
Hmm.
This
Clock.
input.
Hmm. So because of this delay is depends upon the first circuit only, not the individual
Yes.
circuit. Okay. So that's why synchronous circuits are producing the faster output. Sorry, synchronous circuits are producing the faster output. Synchronous circuits are producing the delayed compared to that asynchronous. Okay.
Yes.
Hmm. Understood. Synchronous and asynchronous difference.
Yes.
Hmm.
Yes.
These are the synchronous circuits. Each and every time the clock is giving, right? See, previous one is not giving the clock signal, but every time here giving the clock element. That is the synchronous sequential circuits. Okay, synchronous sequential circuits means the state is affected with every time the instant of time. That means every time the delay will be affecting that. Okay, so that is the synchronous circuits. Okay.
Yes.
Hmm. So what is the difference between the flip-flop and latch? So flip-flop and latch both are bistable, and then both are also stored as a 1 bit storage device. Okay, so flip-flop is also stored like 1 bit, either 0 or 1. We will be stored that, and then here what is the main difference is that the flip-flop will be work with the clock element, so the clock signal will be giving that. Okay, every time it will be depends upon the clock, and here the triggering will be depends upon the enable signal. Okay, enable signal is acts like a clock here. Okay, so that's why it is a level triggered level latches are works with the level triggers, and then here flip flops are works with the what it called edge triggered, because this is the clock I'm taking that. So this is the passage clock, and this is the negate clock. Okay, based on the edge, it is working on that. Here, not like that. Enable signal, that means zero at start, at the starting level only it is working that. Okay, so it checks the inputs continuously and responded to that change of the inputs immediately. Okay, whenever we are giving that 0 or 1, okay, so then it will be checking that. If we are enable is 0, okay, so then the outputs are not getting anything. So outputs are not responded. Whenever the enable 1 we are giving, so then the outputs will be producing that. Okay, so both are same circuits, but here also D flip flop, JK flip flop, T flip flop, all these things are there. Okay, so here latches are there. Instead of clock, here we are using the clock, here we are using the enable pin. That's it. Okay, see, that's what latch flip flops are having the clock, latches are doesn't have any clocks. Okay, flip flops can be built from the latches, and then latches built from the gates. Whatever the gates we are having, so that is the latch. Okay, so then here, whatever the flip flops we have designed, from the latches we are designing that. Okay, so that means I will be designing the latch here. Okay, so this is my NAND gate latch. So just inputs are giving here, and then outputs I am getting. Here also storing the single bit element, but here whatever the element we are having, some some uh, enable pin will be giving by external circuit. Okay, so this enable pin is giving, then only this circuit will be operating, otherwise it is not operating. Okay, just I want to show the diagram here. Hmm. So this difference I have already explained you, right? Synchronous circuits and asynchronous circuits. Synchronous sequential circuits whose behavior is defined from the knowledge of the signals and then discrete instance of time. So every time we are giving the different elements of time. Are you there, guys?
Yes, sir.
Okay, okay, fine. So asynchronous circuits, whatever the the circuit in which the change in the input signals can affect the memory elements at any instant of time. Okay, that is called as asynchronous circuits. Okay, so here clocked flip flops are acts as a memory elements. Here unclocked flip flops are acts as a so unclocked flip flops we are giving that. Then time delay elements is used as the memory elements. See, we have seen that, right? So this is the combinational circuit and this is the memory element. This memory element acts like a delay element. Okay.
Okay.
Hmm. So here the synchronous circuits are slower because each and everything are having the element memory element. This is the combinational circuit, and this is the memory element. This memory element having the clock. Okay, that is the reason every time we are giving the clock means so the delay will be happening, right? So this is the combination sequence synchronous circuits representation. Asynchronous circuits means so this combinational circuit will be there and memory element will be act as a delay, so then there is no other delays except external delays are not available in this asynchronous circuit. But here the designing is very difficulty because one circuit output we are giving to the next circuit clock. Okay, so then the next output is giving to the next circuit. Okay, so this designing is when you are designing the complex circuits it would be creating some problem, but the delay will be less and faster response will be coming here asynchronous circuits. Okay.
So you said faster response for
hmm.
asynchronous.
Yeah, asynchronous is the faster response because
Why?
clock is not there, right?
So, but
hmm.
it is depending on the delay, right?
It
Like
is
even though the clock is not there, but we
hmm.
are using the clock as
Hmm.
the next state is considered as the clock, no, sir?
Hmm.
So it has to wait till the clock is generated, right? So I mean, the output comes, then it is given. That output is given as a clock to the next circuit, no, sir? So it
Yeah.
is like a ripple
hmm.
thing. So how
Hmm.
that is faster, sir, as compared to synchronous?
See, here once only the clock is there. Okay. So then output we are getting the output here. Okay, some output we are getting that output immediately giving as a clock, right? So then again whenever the clock is whenever the first response is coming and then immediately second response also I'm getting that. But here synchronous again I'm giving the clock here. Okay, so here 10 seconds delay and then here 10 seconds delay, so then the response will be delayed by 10 plus 10 20. Okay, and again here I'm giving the 10 seconds delay, then the total delay is 30. But synchronous is not like asynchronous is not like that. Here I'm giving the 10 seconds delay, that 10 seconds delay only is getting the output delay. But compared to the synchronous, so this is 10, 10, 10, 30. So 40 seconds delay it is getting that. Okay, because
So, but that should be opposite, right? In synchronous, in asynchronous, it
hmm,
should be the output should be generated at 10 t is equal to 20, or maybe
hmm,
the next
hmm.
output. But at synchronous, at t is equal to 10 only, we are giving the clock to all the circuits at the same time itself, no, sir?
Okay, but t equal to 10 only, all that we are giving, right? But this will be executing like a sequential type. So this will be, suppose s equal to 0, r equal to 0, we are giving that 1 second, 10 seconds delay. And the next state, so s equal to 1, r equal to 1, again 10 seconds delay. This delay will be added, right? So previous delay will be added to the next delay. So previous delay, first circuit delay will be producing at 10 seconds delay, and then second circuit is also taking 10 seconds delay. Then 10 plus 10, so 20 seconds delay it will be taking that. Okay.
This I did not understand so properly.
See, I'm taking 10 seconds time to get the output from my side. Okay. And
So you
you
are
also
saying for synchronous or asynchronous?
synchronous.
Okay.
Okay, so synchronous because see the in synchronous only we are having the circuits connection like this. Okay, this is one circuit, this is another circuit, and this is another circuit, and this is the another circuit. Okay, so then here also I am connecting the clock. Here also I am connecting the clock, individual clocks. Okay, so this is the clock and this is the clock. Okay, so I'm having the clock here 10 t equal to 10 second. every circuit will produce the 10 seconds delay, 10 seconds delay, 10 seconds delay, 10 seconds delay. Okay, this is also 10 seconds delay produced, this is also 10, this is also 10, this is also 10, then total is 40 nanoseconds. Okay.
Yes, sir. Why?
uh,
Because the output will be generated at like
uh,
a ripple.
ripple type. So here only I'm giving the clock, okay, that is 10 seconds delay, and giving the input, and then this output I'm getting, then this output will be given as a clock circuit. Okay, see, then first circuit only 10 seconds delay will be getting, and the next cycle one there is no delay for this. Okay, so again I'm getting the output, and again I'm getting the output here. Okay, so then total delay is 10 seconds only. Compared to that, so here there is no clock for this external clock.
Yes, sir. But the second
Mm.
circuit
Mm.
will
So
wait for the input, no?
yeah,
So it's
yeah,
like
we'll wait for 10 seconds only. So whenever 10 seconds we are getting, then immediately we are getting the output here. Okay, here t 0 seconds delay only we are getting. Here t equal to 0 seconds only we are getting the output. Here also we are 0 seconds delay only we are getting. The first one only giving the 10 seconds delay, then next one there is no delay.
so there will be a delay, right, sir?
Why?
Because the
How? First
processing,
First one
like the
circuit
circuit.
only first circuit only maintaining the 10 seconds delay. That 10 seconds delay, everyone it is maintained. But here everyone is maintaining the 10-second delay. I am also 10 seconds. So I am giving the response, but 10 after 10 seconds delay I am getting that. And then second one also 10 seconds delay, they are taking that. So here first one only getting the delay. The second circuit is not taking any delay, because this response is waiting for the response only. Then response is coming, then immediately he is responded, immediately he also responded, immediately he also responded. Then the last three circuits are not having any delay. Suppose, how can I say that, um, see, first I'm reaching that, from you. Okay, whenever I'm reaching that, it is taking some 10 seconds delay. Okay, so then whenever I'm reaching that, I'm hand over the deliver packet, that packet immediately you are giving to the next circuit. Okay.
Yes, sir. But that
Ah,
packet will act like his input, no, sir. Here, if you
input.
consider
Ah,
asynchronous one and the
yeah.
second clock, so
Ah,
here, sir, where is the input? Like input should also be there because this is a sequential circuit.
yeah,
So the input,
input will be coming here, so the input will
yes,
be
sir.
taking here, this is the
And
input
so
will be.
since it is a
Ah,
sequential circuit, it will take time, no, sir, for the feedback as well.
which one feedback?
These are all sequential circuits only, no, sir. One, two, three, four in
One, two, three.
asynchronous.
These are all
Yes.
D flip flops. These are all D flip flops. Okay.
Okay, so here,
Uh,
if they are sequential circuits, then the memory element and the feedback loop is also considered, no, sir?
this is the flip flop internal circuit. The flip flop will be designing like this. Okay. The D flip flop circuit will be connecting like this. Okay.
Yes, sir. So even if we
Uh,
are giving a clock from the
uh,
previous one, still it
mm,
will take time to, it won't happen in t is equal to zero, no, sir? The last D flip flop and the first D flip flop,
mm.
because
See, just considered four members are sitting in a row. Okay. So then
so that logic I don't understand, sir. Can you explain with respect to circuit only? Sir, you're not
going to
audible.
the next packet, I will bring that,
So
and
your
I'm
voice
giving
broke.
to the second person. Okay, so again
So
I'm
your
going to
voice
that,
broke.
and again this giving that third person 10 seconds delay, then total every time 10 seconds, 10 seconds for. three persons, then the delay will be having the first person only. The next persons are not taking the delay, right? Can you understand? Have you understood? The four persons
Your
are sitting.
voice broke in between. I could not understand anything. That example itself. Your voice is breaking in between.
Okay, now it is okay, right?
Yes, sir. But
Huh.
whatever you explained, I could not hear anything.
Okay. See, then four persons are sitting in a row. Okay. So in a row, the four persons are sitting means, so each time I am only going the individually. So first person I am going that, and then it is taking 10 minutes time. After that, second person I am going to that, and again 10 minutes time, and then third person I am going to that, again 10 minutes time, and then fourth person 10 minutes, so then total 40 minutes late here. Okay, so I am the only person individually giving to that, because I am having individual time delays every time. Okay, so
Okay,
then
sir. But here
ah
that is not because of clock. That is because
ah
of the input getting,
ah
I mean
ah
the output getting at
mm.
every stage,
Every
right?
clock, every stage.
Okay.
So then I'm taking four packets at a time, and then first person I'm giving that. So the first person keeping one packet, and then remaining three packets are shifted to the next three persons. Then there is no delay for the next three persons, right?
Uh, so, but giving one packet again, it is the same thing only, no, sir. Whether you are giving
Hmm.
it or the first one is giving
Yeah,
it, it is the
first
same, right?
one, but the again I'm going to take the packet, then delay will be there, and that is giving to the next person. That is the delay causes, right? Four times, three times delay, four times delay, every time it is causes. But the first person is having the output, and then again immediately is giving to the next person. Then there is no delay for that, right? Because there is no clock for that. Output is acts like a clock. Then output we are getting the immediately, so at zero time delay we are getting the output. So then next person, who, where is the delay, where is the clock?
I did not understand, sir. Like the first person has four packets, it is giving it to the
Yeah,
next person
next
four
person.
packets. Next person is giving it to
Uh,
the other person. But the giving
I'm
time, are we considering that as clock
see
or what is
see
clock?
See, Riyanka, I'm taking four persons are sitting in a row. So every time I'm individually meeting that persons, then 40%. See, remaining persons will be waiting for their own time, right? Because the first person is taking 10 minutes. Okay, so then the person is completed that, and then next person is coming to the entering into my room, and then he is also taking 10 minutes time. Okay, then every time is
So
40 minutes.
synchronous, I
Uh,
understood. I'm not
ah,
able to understand asynchronous why it is taking only 10
ah.
nanoseconds, for example.
See, 10 nanoseconds, why it is taking that means, see, one person I'm giving the one person only PA is there in my room. Then I have explained that data. So then I'm busy. So then he's taking the 10 minutes time to respond from your side. Okay, then whenever he's coming out, and then he's explaining that one, then it is immediately the three persons are receiving the data. Okay,
Yes,
so
but they are
then
not connected parallelly, no, sir. They
uh,
are
they
connected
are not,
serially. That's why
yeah,
I'm
they
concerned.
are
Like,
not connected parallelly, but there is no delay to pass the information between the first one to second one, because there is no clock in here. Okay, the output response only there. Okay, individual
so
clock is
my
not
doubt
there.
here is that,
Hmm.
like, even if the individual clock is not there, that is
Hmm.
fine.
Hmm.
But since it is also acting as a ripple only, no, sir. So it should have a delay. Like output of, if you consider the second diagram that you have
Hmm.
shown for
Hmm.
asynchronous, there is only
Hmm.
one clock given at 10 nanoseconds.
Hmm.
So I'm giving the input as D. The
Hmm.
output of that is
Hmm.
given first. The output has to be generated. For example, if the
Hmm.
output is generated after 10 nanoseconds, because the clock is considered as 10 nanoseconds. So the output will be generated here. That is given as an input to the next circuit, the next whatever
Priyanka,
sequential
Priyanka,
coming.
wait a minute. Suppose one train is started from Mumbai, so he's late at that 10 minutes late. Okay, so then every time, every station is reaching that 10 minutes delay only. Okay, so entire your journey 10 minutes delay only it is there. Otherwise, he's late at that first station, and then next station is also 10 minutes delay, and then next station also 10 minutes delay, then you are reaching the fourth station at 40 minutes delay. So have you noticed the difference between this synchronous and asynchronous?
Okay, now I get it. So
Huh?
synchronous is like it is getting delayed at every station,
Every station, yeah.
and here it is getting delayed
Only
only by
first
10
day,
minutes.
first second, first station only you are getting the delay, and then there is
Okay.
next times there is no delay, and then departed early. Then it you are reaching at that time. What is the how much delay you are getting? Synchronous and asynchronous?
Yeah, so in synchronous,
Hmm.
the delay would be like 40
Ah.
minutes, 40
Hmm.
nanoseconds. Here
40
it is the
nanosecond.
delay is only 10 nanoseconds. Okay, okay.
Hmm.
So here we are considering only the delay. That is why we
Delay.
are thinking that, okay,
Ah.
okay. All right, all right. I got it now. Yeah,
Hmm.
it was with respect to delay. I was thinking with
Yeah.
respect to inputs.
No, no. So with respect
Okay,
to
got
delay.
it, got it.
Hmm. So is there any images I want to search? Hmm. See this image. Hmm.
Not
So
visible, sir.
yeah,
So
here.
here you can maybe
Ah.
add one more thing while explaining. Like when you
Hmm.
give the inputs, so the
Hmm.
inputs are delayed by that much. Here the I was only considering like
Hmm.
the clock is already given. When you give the
No.
input, then I think
See,
yeah, now it is
see
clear.
here the clock is every time is there, right? See, in
Yes,
synchronous
yes,
4-bit up counter, every time the clock is there. So here only one clock we are giving that. So then the next one is giving to the clock of this one. Okay. So
yes, sir.
yeah. So then
I got
again,
it, sir.
uh,
Delay, it is with respect to delay.
delay.
I was not able to understand, like, I was thinking it with respect to inputs
Then
only.
I'm thinking that this one, so then this train example, maybe you are getting that. Yeah.
Yeah.
Okay. Okay, fine. No problem.
Yes, got it, got it.
Hmm. So then these are the latches, SR latch, how it is working. Okay. So if you are giving S equal to 0, R equal to 1, so s equal to 0 and r equal to 1, we are giving that. And then r means reset, s means set. Okay. If r equal to 1, this q value will be 0 and s value will be 0. Then q bar is equals to 1, we are getting that. How it is getting that? So then again, s equal to 0, r equal to 0, then q equal to 0. Then q bar equal to 1. So just this is acts as a reset equal to 1 means that is the memory state 0 state. Okay, that 0 state how it is working like this. See, this is the r value equal to 1, and then s value will be 0. Okay, so according
Are
to
you
that.
showing anything or are you explaining anything? Because it is still the old SR latch working diagram only.
Okay, you're not saying anything.
No, I mean the one that you were explaining earlier, right? The delay part. That
Huh.
page only are you explaining?
No, no, I have changed to, I have moved to open the ppt, right?
No, PPT is not there. I mean, PPT is not showing up.
Now I will share the screen.
Okay, okay.
Now it is visible.
Yes.
Okay. Here memory element states how it is storing that memory 0 and memory 1. In the memory 0 condition, case 1, s equal to 0, r equal to 1. So in this condition, the memory element should be 0 state. So because r equal to 1 means resetting the output, so that will be stored as a 0. Okay, so that's what I am showing here. See, so this is memory state 0. Okay, so r equal to 1 and s equal to 0. What is the value you are considering? Q value is 0. Okay, so this 0 is going here, and 0 plus 0 0 0 bar is 1. I'm getting the output is 1 here. Again this 1 is going here, and then 1 plus 1, 1 bar 1 plus 1 means 1, 1 bar is 0. So then next state output is 0. So here it is storing that 0 memory state, okay, during the reset condition. Similarly, NAND gate also we are working like that only. So s equal to 1 and then r equal to 0, that is the memory state 1. So how we are storing the memory state 1 means, see, r equal to 0, s equal to 1, then q value will be taking as a 1 here. Okay, so then this value will be stored here. Okay, 1 plus 1, 1 bar. So 1 bar is that 0. Okay, you are getting the output is 0. Then 0 is going here, 0 plus 0 0 bar, 0 bar is means 1. Okay, that is the state memory state 1. Clear? So this is the present state, and the next state is also we are getting 1 here. So every time it is storing the 1 only, that is the memory state 1. And every time it is storing the 0 only, so that is the memory state 0. Because again you are giving 0 here, the next output 0 0 plus 0 0 0 bar is 1. Okay, this 1 again giving to here, and then 1 plus 1 1 1 bar is 0. Okay, so in this way we are getting the memory states 0. During reset condition, the memory state is 0 only. Depends upon the q value. Q value is that 0 or 1, it stores the 0 value only. Okay, you can see here the truth table. So 0 0 state, the no change condition. No change condition means whatever the previous state output is there, that is only we are getting that. Okay, and then reset condition means this is the s means set condition, s means set condition, r means reset condition. R means reset condition, and then s means set condition. During that set condition, my output should be set. That means it will store that one value only. Wherever the value is there, okay, it stores one only. Okay,
So here I have one more question. Like, why it is not called a flip flop but SR latch?
see, latch and flip flop, here it is having enable pin. Okay, so if we are using the clock signal means, then it should be flip flop. Okay, your circuit will be, see,
So
there is
where
no
you were showing?
huh,
Okay,
just
okay.
hmm, just I want to show you the latch circuit. This is the enable signal. Okay, here we are giving the enable signal only. Replace this enable signal with clock. Okay, so then we will consider it as a flip flop. Okay, so this enable pin will be working with 0 or 1 only. If you are giving the 0, if any value giving as an input and you are getting the output is not getting any output. So t plus q of t plus 1 is the output, so it is not getting anything. So previous value, whatever the previous value is there, that only it will be storing that. And then similarly, s equal to 0, r equal to 0, enable equal to 1, at that time also no change condition, whatever the previous value is there, same will be stored in that flip flop, sorry, latch. Okay.
So that's what, like, on
uh,
general terms, not with respect to the truth table, but
mm.
why, when we use latch and when we use flip flop, like, how do I understand that, okay, now I have to use latch or now I have to use a flip flop?
Suppose in your each and every circuit there is a clock signal means, then we will use the flip flops. Okay, here flip flops are used. So latches means it is also stored element. Suppose I want to enable the pin. Okay, so then I'm not depends upon the clock. So either clock, either passage or negage. Okay, so I don't want to use this clock. Then I want to use as a switch. Okay, so if turn on the switch, I want to get the output. Whenever turning off the switch, okay, I don't want to get any output at that time. It will be used as a latch. Okay, so every time we are changing that, see, every time we are changing the values of input based on the clock signal, so we will use as a flip flop. Because in our real time industries, most of the registers are changing, okay, their values with respect to the time. Okay, not turning on the not turning off that, not turning on. So every time we are not turning on and turning off, so internally the clock will be there. The every time the clock is changes means the values will be changes. Okay, at that time we will use the latch flip flops.
So when we want the values to change based on the
The
clock,
time,
we use flip
yeah,
flop.
we will
If
use the flip flops. Hmm.
okay, and if we want
Hmm.
at level, then
We will
switch
use the
or latch.
latches. Yeah. So you
Okay,
want
and
to
the
change.
buffer, they are also considered as latch only, or latch.
A buffer is a general storage purpose. If you want to give any delays between the input and output, you will store the buffer. You will add the buffer. That buffer will be storing the data temporarily. Okay. So then that will not affect any data. Whatever the data you are giving, that data only it is storing that.
So, but it is considered as a flip flop or as a latch, sir.
No, so latch or flip-flop, it is not. Suppose you are giving some control signal, that control signal is based on that 0 or 1, then it will be acts as a latch circuit only. So because this buffer is having some control input, so without control input, so that will be acts like this is the buffer signal. If you are giving the control signal like this, okay, so this is the control signal. This control signal is giving 1, okay, then only I'm getting the output A. Okay, otherwise if we are giving 0, then whatever the input I'm giving, that is not getting some unknown value we are getting. So based on the control signal means we are operating the input. Okay, so this is
Okay.
not depends on any clock. Okay,
Okay. So it is
yeah,
neither flip flop nor a latch.
maybe.
Okay.
So,
Okay.
hmm. Okay, see flip flop. What is the SR flip flop we are having? Same thing, but here what is the what is the element we are considered here? So clock only we
Clock.
are considering. Yeah. So based on the clock signal, we are operating this one, either NOR gate operation or NAND gate operation. Both are different. Okay, so circuits operations are same, but states are different. Suppose if you are taking the NOR gate, whenever we are giving the values at high, 0 will be treated as a off condition, 1 it will be treated as a on condition. Whenever you are using the NAND gate, 0 will be act as an on condition, 1 will be act as an off condition. Because you know that NAND gate operation, right? So then 0 1 0 0 0 1 1 0 1 1. If both inputs are 0, I'm getting the output is 1. If any one of the input is 0, I'm getting the output is 1. Not both the zeros. Okay, so if both the inputs are 1, I'm getting the output is 0. Okay, so here reverse operation we are doing that. That means if your values s and r values, s and r value 0 0 means that is invalid condition, not taking any value. Okay, and then 0 1 means that is set condition. Whenever 0 is there, that is operating that, and 1 0 is there means that is reset operation. Okay, and 1 1 means no change condition. Okay. See here, not like that. So S and R flip flops, 0 0 is there means your output will be no change condition, and then 0 1 means reset condition. Okay, 1 0 means set condition, 1 1 means invalid condition. Okay, if both are 1, we are getting the invalid output. So that is the truth table of SR flip flop. Okay, so based on the truth table, we are build that characteristic table. See, 0 0 means you're holding the output. Okay, that is the no change condition. Whatever the qn value is there, that will be appeared at the qn plus 1 state. Okay, so we are getting two outputs like this. Suppose S and R flip flop, I'm giving the two inputs here, and then clock signal. Okay, this is the clock signal, this is S and this is R. I'm getting the two outputs like this. One is Q, if I'm taking Qn, and then this is Qn plus 1 type. Okay, this is the output I'm taking, that Qn plus 1. Whatever the Qn plus 1 means, so same output, whatever the Qn is there, same output will be appeared there. So no. So this is the Qn bar. So this is the Qn output. So same, that next state is that Qn plus 1. That next state output only we are getting that. So the next state output is nothing but whatever the Qn is there, that will be holding that. Okay, that is the SR flip flop holding condition. Whatever the Qn is there, that will be holding for the next state output Qn plus 1. So during that, S and R will be 0 0. Okay.
Okay, so the
uh,
circuit internally has that memory element feedback. So that is why,
Feedback
yeah.
element, all these things are internally we are giving that. Okay, because I have shown you now. So this is the
Yes,
circuit
yes,
diagram.
this one.
Yeah, this entire sequence, so symbol is this, and then internal circuit is like this. Okay, this is the internal circuit. So simply we are calling as a SR flip flop. So inputs are giving like this. Whatever the inputs I am giving, S and R clock, and I am getting the outputs like Q and Q bar. Okay. So this is the truth table. From the truth table, I'm designing the characteristic table. I told you now. So what is the condition? 0 0 case. So during the 0 0 case, okay, this is no change condition. No change condition means Qn plus 1 equal to Qn. So that means 0 is giving, then Qn plus 1 is also 0. And 1 you are giving, then Qn plus 1 is also 1. How we are writing this characteristic table means, I'm taking that S and R is the inputs, S R is the input, and then Qn is the present state input. So 0 0 0 0 0 0 1, three inputs I'm considering. Then 8 combinations we will write, right? So 0 0 0 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 triple 1. Okay, so based on this Qn plus 1 next state output, I am defining that. Okay, how I am defining that? If it is 0 0 means, then S and R flip flops are 0 0 means, we will write here. Okay, S and R 0 0 0 1 1 0 1 1. So this is the Qn plus 1 output. So the output will be no change condition. That is, Qn is whatever the Qn is there, that will be appeared at the Qn plus 1. And then 0 1 means reset condition, the output will be 0 only. Then Qn equal to, see, Qn is 0 or 1, I don't care about that, my output will be 0 only. Okay, so then 1 0 means set condition, that is 1 only, it is storing that. And then invalid condition, so during that 1 1, I'm not getting any valid condition values, every time it is changing, that is the invalid condition I'm telling that. Okay, so this output will be 0 and this is the 1, and again, so this is the no change condition. And then 0 1 case, this is reset condition. During reset condition, Qn is 0 or 1, I don't care about that, Qn plus 1 is 0 only. Okay, and again 1 0 condition, this is set condition. Set condition means, so if you are giving 0 1 value, so if it is 0 or 1, I am setting the value is 1 only. Okay, and then 1 1 condition invalid. Okay, so invalid condition, during that invalid condition I'm getting the unknown values. Okay, we are not getting any known values. Something will be 0 or 1 or 1 0 every time, it is changing that. So that is the reason we are taking the invalid condition. Yeah, any doubt in this characteristic table?
No, sir.
Huh. So this output we are considering here, Qn plus 1 is the output. For that we are doing the K map for this. Okay, so this value is 0, 1, 2, 3, 4, and then 4, 5, 6, 7. Okay, where we are getting ones here at one position, and then fourth position and fifth position. Okay, this will be taking as an invalid conditions, that is the don't care values, I'm getting that. Okay, so at 6 and 7, this is 0 1 2 3 4 5 6 7. Okay, so where we are getting ones here, one position 1, and then fourth position value I got 1, and then fifth position I got value 1, and then sixth and seventh we will get the value don't care values. Okay, so then what is the output we are getting here? This is the output. Okay, this is one pair. This pair is what? So R bar and Qn, and this is S bar and S. So Qn plus 1 output is what? Qn plus 1 equal to, so this will be added together and we are getting value 1 only, S only. Okay, S plus, what is the output we are getting? R bar into Qn. Okay, R bar into Qn. So this is the output I am getting. Okay,
Okay, sir.
and hmm, same thing, excitation table. How we are getting the excitation table means, based on the Qn and Qn plus 1 value, the S and R values will be decided here. Okay, so in the previous one we have drawn the characteristic table, right? So from this I will write the excitation table. This is my Qn, and then Qn plus 1, and S and R. Okay, Qn conditions, four conditions are there: 0 0 0 1 1 0 1 1. These four conditions, what about the S and R values? Check this. So same values will be there. Okay, huh. So what is the condition I'm checking here? Qn is 0, Qn plus 1 is also 0. Okay, this is the condition. Where we are using this excitation tables means, one flip-flop is converted to another flip-flop. At that time we are using this excitation tables. So 0 0 I'm giving that. So 0 0 case, what is the value of SR value? S value is 0, R value is also 0. Any other case is there? So here only, here also another case is there. And then check that S value is 0 here, and S value is also 0, but R value is changing. R value is 0 here and R value is 1 here. Then so S is 0 and R is don't care condition. Okay, that's what he is written here. Okay, S is 0 and R is don't care condition. Okay, and then again what is the other condition? 0 1 case. So 0 1 case, only one case only it is available, there is no other cases. Then what is the value of S and R? 1 0. Okay, S is 1, R is 0. And then 1 0 case, 1 0 case is also having only one value. Then 0 1. Okay, S value is 0, R value is 1. Okay, that's what he is written here. Okay, 1 0 case. Okay, 1 0 1 case, 1 0 1 0 case, reverse of the inputs, that's it. Okay, and again 1 1 case, this is the 1 1 case I'm having. Okay, and this is also 1 1 case. Okay, at this time, S value is 0, R value is 0. S value is changing here, R value is maintained 0. That means S is don't care, R value is 0. Okay, S value is don't care value and R value is 0. So these flip-flops where we are utilizing means registers purpose, register storing the values that will be maintain the registers values, and then counters, also we are utilizing this SR flip-flops, all these things, and memory elements, some synchronous systems, all these things are we are utilizing these flip-flops. Okay, where we are utilizing this excitation tables means to convert SR flip-flop to JK flip-flop. At that time we are utilizing this excitation table, or SR flip-flop to D flip-flop I want to convert, or SR to T flip-flop I want to convert. Okay, any type of conversion we will go through this characteristic table and then excitation table. From the characteristic table, excitation table will be getting. This characteristic table where we are getting means based on the truth table. Okay, truth table defines you that operation of your flip-flop. Characteristic table will defines you the behavior, and then excitation table will tells you that conversion of one flip-flop to another flip-flop. Clear?
Yes.
Huh. Same thing, D flip-flop operation. D flip-flop is whatever the SR flip-flop is there. So that should be connected to C, S and R. So this S will be connected to the R with one NOT gate. That means reversing the input value. Okay, S value is reversing here only. And then clock is connected to this one. So same thing, this is the gated SR flip-flop. Okay, so this gate is operating like a clock. Okay, this is clock and this is flip flop. So then gated flip flop we are connecting. Same thing here also. If we are having the D flip, the clock is 0, the D flip flop is giving any value 0 or 1. I'm not getting any value, so the no change condition. Okay, so memory is no change condition. I'm not taking any value. Whatever the Q value is there, whatever the Q bar value is there, same values will be stored here. And then whenever clock is there, D value is there means, so here reset and set conditions only there. D is 0 means it is operating like a reset condition. Reset condition means your output will be 0 only. And then a set condition, if your D flip flop is 1, I'm setting the value is 1. So that is the output. Whenever the output is set condition, the output will be set to 1 only. That means you are giving D flip flop is 1, I'm getting the output is 1 only. You are giving the 0, I'm getting the 0 only. That is the reason D flip flop, it acts like a whatever the input we are giving, same output we are getting without any change. Okay, so that's why D flip flop is also acts like a buffer. Okay, buffer, how it is storing the value. So whatever the input we are having, giving the input, the same output we are getting, same input we are getting at the output side. Okay, clear? D flip
Okay.
flop condition. Can you tell me the characteristic table for this one? So what is that? So truth table is nothing but if you are having D flip flop is this is D and this is Qn plus 1. If you are giving 0, then your output will be 0. If you are giving 1 and your output will be 1, this is reset condition and this is set condition. Okay, so this D flip flop will be acting like this. Okay, based on this characteristic table, can you tell me? This is the characteristic table. Okay, so what is the values we are giving? D, Qn, and then Qn plus 1. Two inputs I am giving. So 0, 0, 0, 1, 1, 0, and 1, 1 case. See, this is the D0 case. What is the output I am getting? Qn, right? Okay, so no change condition. This is the, sorry, uh, no, this is no change condition. No change condition means whatever the Qn is there, then Qn plus 1 is also same thing. Okay, So 0 is there, 0 will be getting, and 1 is there, 1 will be getting. Whenever D is there means I'm getting set value, so that will be set, and then 1. This is the T flip flop characteristic table. See, same thing. Okay, sorry, I have explained the reverse condition. This is the reset condition only. Okay, whatever we are explaining that. So D0 means we are not getting anything, right? Okay, so that is reset condition only. Okay, D is 1 means set condition. Whatever the Qn is there, and then Qn plus 1 will be the output is 1 only. Okay, so that is the truth table. I am explaining that. So truth table D is 0 value, that is reset condition. Reset condition means Qn plus 1 equal to 0. Whatever the Qn value is there, that Qn is 0 or 1, I don't care about that. Okay, so that reset condition, this is D value. And whenever 1 we are giving that set condition, that means Qn plus 1 equal to set to 1. Okay, so that's what we have written here. Okay, so this is 0 and this is 0. Okay, Qn plus 1 is also 0, this Qn plus 1 also 0. If it is 0 or 1, we don't care about that. This is reset condition. Clear? Any doubt? This is set condition. Okay, so then based on this, we are writing the excitation table Qn and Qn plus 1, and then D value. So this is reset condition. Qn is 0 or 1, and Qn plus 1 is getting 0 only. This is set condition. Qn is 0 or 1, that Qn plus 1 will set to 1 only. Then check the condition 0 0 case. Okay, 0 0 case, what is the value? D value 0. And 0 1 case, this is the 0 1 case, D value is 1 only. Okay, and D is here, output I got 1 means D is 1 here. Okay, and 1 0 case, so then D value is 0 only. See, this is 1 0 case, D value is 0 only. Okay, and 1 1 case, D value is 1. Am I clear? D flip flop, how it is working?
Yes, sir.
Huh. See, that is the output 0 0, and then Q D value is 0. JK flip flop, in SR flip flop we are having some invalid condition, right? So whatever the illegal condition is there, so that will be avoided in this JK flip flop. Okay, this JK flip flop toggling will be there. Toggling means the 0 will be converted to 1, 1 will be converted to 0. Okay, that feature is there in this toggle or leading edge of the T flip flop, JK flip flop. This is the JK flip flop. I'm giving the J value, K value, and clock. I'm getting the output Q and Q bar. So this is the internal circuit. See, the output is connected to Q is connected to this gated flip flop. Okay, and then Q bar is connected to this one. Then the S and R values will be changing here. Okay, just like SR flip flop, whatever the SR flip flop we are writing, and then Qn plus 1 is also same. So what we are writing, 0 0, no change condition, that means Qn plus 1 will be getting that Qn only. And 0 1 case, reset condition, my output will be 0 only. Okay, this is reset. And 1 0, then set condition, I'm getting the 1. But 1 1 case, toggle condition we are getting, just replace this S and R with JK. Okay, so toggle means if your Qn bar is Qn plus 1 equal to Qn bar I'm getting, that means Qn value is 0. Okay, Qn plus 1 is 1, I'm getting that. Okay, and then Qn is 1, and then Qn plus 1 is 0, I'm getting that. Clear?
Yes, sir.
Hmm. See, this is the truth table. and then characteristic table. How the truth table we are having, this is the, actually he is not mentioned that this is the truth table. Okay, jk present state and next state. If you are 0 0 k value, j value 0, k value is 0, the next state output is same, qn is there, whatever the qn is there, so that will be the same output. And 0 1 case, okay, whatever the output, that is the 0 only. And then 1 0 case, set condition, this is set condition, this is reset condition, this is no change condition, this is toggle condition. Okay, so then characteristic table, how we are saying that 0 0 0, then whatever the qn value is there, same qn plus 1 also we are getting. And then 0 0 case, whatever the qn is there, same value qn plus 1 also we are getting. And then 0 1 0, so that is reset condition, this is reset condition. Then whenever qn is 0 or 1, okay, I'm getting the output is 0 only. Okay, these two conditions are same. And then set condition, whatever the 0 or 1 present in my qn, the next state output will be 1 only. And then 1 1 case, this is the toggle condition. So during this toggle condition, qn is 0, then qn plus 1 is bar, that is qn bar. Okay, so 0 will be converted to 1 and 1 will be converted to 0 here. Okay, toggling condition. Then check that qn plus 1, where we are getting ones here. So this, see, in the d flip flop also we need to find out that k map for this one, where we are getting the k map. See, this is the output I am getting, right? D output, sorry, qn plus 1 is the output, right? So what is the output I am getting here? So qn plus 1 equal to d only, I got that. So this is the qn plus 1, d and qn I'm giving that. This is 0 and this is 1, this is 0, this is 1, 0 1 2 3, where we are getting the ones here. 0 case 0, 1 case 0, and then 2 and 3. So 2 and 3 I'm getting the 1, so this will be forming as a pair. Then qn plus 1 equal to, this is d and this is d bar, and this is qn bar, this is qn. Then my qn plus 1 will be, the output is d. Okay, this is the characteristic equation. Similarly, we will calculate the characteristic equation for jk. Okay, what is the jk value here? So here 1 I'm getting 1, and then 4 5 6. So this is 0 1 2 3 4 5 6 7. Okay, so where we are getting ones here? Hmm.
JK QN bar, JK bar
Hmm.
QN.
So these two are pairs forming that. Okay,
Yes. Reducing the
then,
K map basically.
so then here also we are forming the pair. Okay, then j is the common variable, and then q bar is the output. So qn bar and then j, so qn and k bar is the output. Okay, so that is the reason we are connecting that qn bar is connected to input and qn is connected to input of k bar. Okay, that is the reason we are connecting these values. See, q bar is, q is connected to k bar, and then q bar is connected to j. Okay,
Yeah.
similarly, huh, T flip flop. T flip flop is having, if T is 0, okay, so the Qn plus 1 is no change condition. No change condition means whatever the Qn is there, same value will be appear at that Qn plus 1 also. T is 1 means that is toggle condition. Okay, so toggle condition means Qn is 0, qn plus 1 will be getting 1, and qn is 1. Okay, qn plus 1 will be getting 0, so that is the qn bar output I am getting here. So if it is 0, no change condition, this is no change condition, q is 0, qn plus 1 is also 0. Okay, if it is 0, q is 1, and qn plus 1 is also 1. If it is 1, okay, toggle condition, it is 0, then qn plus 1 equal to qn bar. Okay, this is 0, I'm getting 1 here, and this is 1. So then again 1 means 0 I'm getting. Then characteristic table, from this only we will write directly. So qn and qn plus 1, 0 0 0 1 1 0 1 1 case. So 0 0 case t is 0. Okay, and then 0 1 case t is 1, and 1 0 case t is 1, and 1 1 case t is 0. Like exclusive OR gate, we are getting the output of t. Okay.
Okay, sir.
Hmm. So apply these values here and then check that outputs. Okay, you are getting the outputs are same or not. Hmm. Same thing, T flip flop, where we are getting ones here, 0th first case, and then second. So 1 and 2, I'm getting ones, say one place and then second place. So this is 0, 1, 2, and 3. Okay. So then what is the output? I'm getting T and Qn bar, and then uh, T bar and Qn. Then exclusive OR gate output operation. Okay. T bar and Qn plus T and Qn bar. Okay, this is the T flip flop. Registers means group of flip flops we will form that. Okay, group of flip flops I will consider that. Then different registers we will form that. Okay, so n bit register you want to form that, then n number of flip flops you need to form. Suppose 4-bit register I want to add this is the 4-bit register, this is one flip flop, this is another flip flop, this is another flip flop. Okay, so 1 2 3 4 4-bit register will be forming, because one flip flop it will store one bit only. Okay, how many bits you want to form the register, then those many flip flops I want to form that. Suppose I want to form 6-bit register, then 5 and 6 will be added together. Okay.
So here one more question, like
Hmm.
these flip flops, one bit, which are storing one bit only.
Hmm.
Those could be anything, right? Like D, SR, JK.
Yeah, SR flip flop or JK flip flop or T flip flop or D flip flop, anyone. So
Okay. And
anyone, yeah, every
yeah.
time it will store one value only. Hmm.
Okay, sir. And so one more
Hmm.
thing, like
Hmm.
they are not connected to each other, right? Like there is
Hmm.
no carry. I mean, not
Uh,
like a ripple thing. They are
yeah.
individual, right?
Yes, yes. So
Okay.
then we are connected different flip-flops in series form and parallel form like this. Then we will form a registers. Okay. See, this is the 4-bit registers. Okay. Why we are utilizing every time D flip-flop means, so D flip-flop is the best one, because whatever the input we are giving, that output that is the producing at the output side. Okay, so that is the reason we are forming, we are grouping together. Okay,
And so here
so
they are
uh,
synchronous, we'll call it, right? Because they are
uh,
carrying the same clock.
because each and every signals are sharing the individual clocks. Okay, so this is clock, this is clock, this is clock. Synchronous register, this is the synchronous 4-bit register. Okay.
Okay, sir. And so
Hmm.
asynchronous registers, I mean asynchronous are also there.
Hmm. Yeah, asynchronous also will be there. Okay, we
Okay,
will see that. Hmm.
got it.
See, this will be acts like a buffer. I told you now. So whatever the input I am giving, okay, it will be connecting like this. So this will be a simple 4-bit register. So that stores the output here. See, individually I am giving the inputs. Okay, parallel
So
input
here,
and
how is it a buffer? Because we concluded that buffers
hmm,
are not flip-flops or latches. They are different. Here it
hmm.
is made of
just
flip-flop.
just storing purpose only, right? So that's why buffer register he is saying that. Buffer register means whatever the input we are giving, same output I am getting that without any change. So that will be called as a buffer.
So here, sir,
Um,
it is like 4 bits. So
hmm,
it is four
hmm.
bit buffer register. So
4
if it
bit
is
buffer
one
is
bit, it is buffer
one
only,
bit
or
1 bit buffer register only. So not that is flip flop, not called the buffer. Okay. So 1 bit it is storing means it is flip flop.
so buffer and flip flop are same only, is it? Or no?
No, whenever we are connecting together, okay, number of flip flops are connecting together, then it will form a register. Okay.
So I don't have doubt about register. I have doubt
Ah,
about buffer.
buffer is a single bit storage device. Okay. So then group of bits you want to form that, then it is forming a register. Okay. So buffer is
No, so
nothing
my
but a
question is
ah,
not about register. My question is
ah.
that flip flop, can we consider it as a buffer then?
No, no, flip flop is not considered as a buffer. Buffer is nothing but just a storage device that is not doing anything, just do storage purpose only.
Okay.
Hmm.
So 1 bit like flip flop is also storing only, no, sir?
Storing only, and then it will store that data whenever you are changing that. Okay, buffer and flip flops. Any suppose whatever the data you want to replicate, we can use the buffer. Okay, but here the flip flop is not like that. It is a memory storage element. If you are storing the same element, and then based on the clock, we are storing the element in flip flop. Okay, so that is not buffer is don't have any clock and then all these things.
So even latch doesn't have. So like coming
Ah,
to the previous question,
latch
what would be the
latch is
difference
depends
between latch
upon the
and
enable pin. Whenever enable pin is there, okay, so maybe latch will be act as a buffer because enable pin is there. That is the acts as a control pin. Okay.
okay, so
Ah,
okay, so fine, thank you.
okay. So just think about that buffer is a temporary storage purpose only. Okay. So here, flip flop or latch we will consider means it is a permanent storage device. Okay, or memory storage devices purpose. Suppose I'm using some pen drive. That is, this flip flop will be storing that data. Hmm. Hmm.
Okay, so
So these are the shift registers. We have four type of shift registers: serial shift register, serial in, serial out, serial in, parallel out, parallel in, parallel out, parallel in, serial out. Okay. So this will be the serial in serial in serial out means each and every value serially shifting that. Okay, this one is going to this one is going to this one is going to that means uh,
here in this now based on whether it is serial or parallel,
hmm,
the asynchronous or synchronous flip flops will be used, right? So
asynchronous will be used or synchronous also we will use. So but most of the times we are using that synchronous registers only, synchronous flip flops only. See, this all, yeah, these all are connected to serially. So this is four registers I'm connecting. That input, one input is connected to the next one. Okay. So the first output is connected to the next one input, and then second one output is connected to the next one input, third one input, and third one output is connected to the fourth one input, and each
so
one
here it
having
will be, sir, yeah,
uh,
asynchronous only, right, sir, or synchronous?
asynchronous. Sorry, synchronous, not asynchronous. So each and everyone having individual clocks. The data will be shifted here. Suppose I'm taking this is my data in and this is the data out. Okay. So here I'm taking the D1 and Q1 is the output, and then D2 and then Q2 is the output. Okay. So D2 what is the value? Q1 is the input, and D3 and Q2 is the input, and D4 Q3 is the input. Now you can consider that Q3, Q2 and Q1 and Q naught. So initially all are zeros. So Q3 is 0, Q2 is 0, Q1 is 0. All are zeros. Okay, like this. After that, I am giving value 1. D1 is 1. Okay, Dn is 1. That will be stored in, see, you can consider like this. This is Q1, Q2, Q3, and Q4. Initially, all are zeros. Whenever D1 is 1, okay, Dn is 1, then Q1 is 1. Remaining Q3, Q2, Q4 will be 0. Okay. So whenever we are giving the data value, so some 1100, I'm giving that. So whenever you are giving the next value 1, okay, this is 1, this will be shifted to Q2. Okay,
Yes,
so
got it, sir.
Q1 is connected to D2, then D2 is 1. Whenever we are giving 1 again here, this is 1. Okay, D2 is 1, and then Q2 value will be 1. Okay, so
Yes, so
whenever I'm
basically
giving,
you're shifting it
uh,
to the right.
yeah, shifting to the right. So whenever I'm giving 0, okay, so 0 1 1 0. Okay, so then all bits will be stored into that Q1, and then so that is loaded. Okay, Q1 is having data, Q2 is also having data, Q3 is also having data, Q4 is also having data, and then that loaded output I'm coming to the out means it will take another 4 clock cycles. Okay, serial in serial output, how many bits are there? Those double the clock cycles. Suppose 4 bits are there means 8 clock cycles are required to get that output is coming out from that register. Suppose 8 bits you are considered means 16 clock cycles are required. Yeah, tell me, any doubt?
Why, sir, 16? It should require only four cycles only, no, sir?
I am not getting, no, 4 cycles, how we will get that? See, this is the
So
serial
similar
input.
to the
Uh,
one we discussed earlier, right? That 40 nanoseconds. It is the same circuit, right? Sir?
Same circuit. Hmm.
So, sir, then why it is taking double, like 80 nanoseconds? It should take 40 nanoseconds only, no, sir?
Uh-huh.
Like four clock
But
cycles
I want
considering.
to get my output out. Okay. See, 4 inputs I am giving here. So then 4 inputs I am giving means, so 1 I am giving here. Okay. So Dn equal to 1. Okay. So that Dn is equals to 1 here, and then Q naught is 1. Okay. So Q naught is 1. This is one output, and then this is one output, and then shifted together. So then 4 clock cycles all are there. Okay, the data is loaded. Okay, am I clear up to this? So all are having the data. Okay, 1 1 1 1. So 4 flip-flops are required. Okay, 4 clock cycles are required. So then I don't want to the values will be not there in that outputs. That means Q0, Q1, Q2, Q3 all should goes to 0. When I will get 0 here? Am I making sense? Hello.
Hello, sir. Yeah, sorry, I was
Hmm.
speaking with muted. Yeah, I
Hmm.
was saying like again, it will require four more clock cycles because when if now Dean becomes zero,
Hmm. Hmm.
then
See,
it will pass through.
see, 4 clock cycles all are there here, right? Then this is Q3, this is Q2, this is Q1, this is Q naught, right? Then again this is moved to right side. Okay, and then these three are moved to this one. This is 0 again, and one bit is coming out. Okay, one is coming out, and then 1 1 0 0 here, and another bit is coming out, 1 0 0 0 here, and another bit is coming out. So all are zeros. Okay.
Yes, sir. So four clock
Hmm.
cycles only, no, sir? Because in
But
each clock cycle, the bit will
but
move shift to the left,
uh,
right?
Yeah, but loading is taking another 4 clock cycles, right?
Which loading, sir?
Data is loading time. See, Q1 is loaded to 1, Q2, so Q0 is loaded to 1, Q2 is also loaded to 1, and Q2 is also loaded to 1, Q3 is also loaded to 1. For this, another 4 clock cycles are required, right?
So like for example, t equal to 1.
Huh. So
Okay.
T equal,
So this
yeah, input is 1. That will be loaded into my Q1. Okay, remaining Q1, sorry, Q0, Q1, Q2, Q3 will be 0, right?
yes, sir. So shifting
Hmm.
this left to
Ah,
Q3,
yeah,
from
shifting to,
Q0 to
so
Q3, it
from
will take
Q,
again 3 cycles only, no, sir?
how
So
3
overall,
cycles?
what I'm saying is 4 cycles only, no, sir? From this shifting this D
Banu.
in 1 to
Huh,
Q3, it will take
see,
only 4 clock cycles, no, sir?
see,
Not
Banu.
8.
So initially all are zeros, right? That will not considered. And then one bit is stored and remaining will be zeros, right? And another bit will be stored, then next one is there, remaining bits will be there. Okay, so then another bit is stored and then Q3 will be 0 and then 4 bits are there. So this is loading time, right? Data loading is taking 4 clock cycles here, right?
Okay, sir.
Q3 is having data, Q2 is having data, Q1 is having data, and Q0 is having data. But this shift register, again I want to store the data. Again I want to store the data. That is not 0 here. Still the data is loaded. Okay. I want to
Okay.
empty this. For empty
Okay.
purpose, how many clock cycles are required? So this one is
Four
coming
clock
out.
cycles.
Okay, this one, and then this moving to, all these ones are moving to right side, and this will be stored as 0 because I'm not giving any data. Okay, and then this
Got
is
it, sir.
coming out.
It will
Yeah.
take 4 clock cycles because
uh,
4 bits are there.
hmm, right.
Got it.
4-bit shift register, you need 4 clock pulses to load the data, and to retrieve the data again you need 4 clock pulses. Then how
Okay.
many clock pulses are required here? 2n clock cycles are required to get the output.
Yes. So if
Yeah.
there are n bits, then
uh,
n bits for loading, n
uh,
bits for
for
taking it out,
retrieving the data.
retrieving.
Hmm.
Yeah. So two n
Hmm.
clock cycles.
Yeah, serial in, serial out. See how it is going the data. So all are 0. So first clock cycle, so each and everything will be taking, all should be 0. Then these many cycles are required. Okay,
Got
and
it.
then
Got it.
serial in, parallel out means, so then serially I'm giving the input, parallelly I'm taking the output. Then 4 clock cycles are required only. Okay, number of clock
Yes.
cycles are required for 4 only. Every time I'm getting the output. Okay, parallel, serial input, parallel output.
Okay. Sir,
Parallel.
one more question before
Hmm.
this. Like, if you
Hmm.
can go to serial in the
Hmm.
previous slide.
Hmm.
Yeah.
Serial
No,
in,
no.
serial
The
out.
next slide.
Okay, serial in,
Serial.
parallel out. Hmm.
Yes, sir. So
Hmm.
here, sir, 4 bits will be, four
Hmm.
clock cycles will be required for loading.
Yeah.
And so 1 clock cycle again will be required for retrieving, right? So five
No.
clock cycles is
Every time parallelly I'm getting the output. Okay. So this input I'm giving, one is I'm giving, so this output is getting here, and then next input 0 I'm giving, this one is going to here, and here I got the output 1, and here I got the output 0. Okay, and then again 1 I'm giving, and this is moving to this one, 1 I'm getting here, and then 0 I'm getting here, again 1 I'm getting here, and then fourth input I'm giving here 1. Okay, 1 0 1 0 I'm getting the output. Okay, so
okay.
yeah,
So when it reaches
reaches,
QD,
yeah,
that time
that
itself
time
it is
also it
retrieved.
is
That's
getting the
why.
output side. Yeah,
Okay, that's why it is like 4 clock
four
cycles.
clock cycles.
Got
Parallel
it.
in, parallel out, only single cycle is required. One cycle is required.
Yes, got it.
Okay.
Because
Hmm.
it is already giving, and in 1 clock cycle only
One
we are
clock
doing.
cycle. Yeah, and then parallel in, serial out. So parallel in, serial out, so parallelly we are giving the loading the data, then shifting the data is serially. Okay,
Again, 4 clock
four
cycles.
clock cycles are required.
Got it, sir.
Okay, so this is parallel in serial out. So the data will be parallelly loading, but this will be, see, data D3 is loaded here. Okay, D2 is loaded here, and then again it is moving to data shifting right. It is taking 4 clock cycles. Okay.
Yes, sir. Got it.
Hmm. So up to this you can read. Then tomorrow, I think next week we'll complete the remaining things. Okay. So
Yeah, okay, sir. You will
you
be
know.
taking us with the new batch only, sir, now?
I will take that. So new batch is that Monday they will start maybe.
Tomorrow only, no, sir?
Tomorrow.
Yes, sir.
Hmm.
So, in case you are completing with them, sir, so that is also fine for me. Banu can suggest if she is okay or not.
Okay, okay.
Yes, sir. So, instead of
Banu.
taking on Sunday or something, it is good for
Hmm.
us.
Hmm. Hmm.
It will be completed with them itself.
Yeah, yeah.
Yeah. So, then
Hmm.
weekends we can focus on either Verilog or MIPI. These
Hmm.
things
So
we can
this
try.
very weekdays, this week we will complete the Verilog. Okay, no problem in that.
Okay, sir.
Hmm.
Yes, sir. So, but you please just don't take theory only. You take
Hmm.
with hands-on as well. Practical. I mean, I'm
Huh.
used to theory and practical both together, not just
Yeah,
theory. I forget.
yeah,
So,
yeah. So
yes.
actually, I want to show you the outputs also, but what I'm thinking is after completion of theory, so then I will show the this EDA playground outputs from these flip flops. First, you need to know the theory. After that,
No, so what I'm saying is after theory, like if you have
mm,
completed marks decoder and these kind of things,
mm,
immediately
mm,
you can take hands-on so that we'll get time to practice also, no, sir. Otherwise,
mm,
only theory, theory, and if you still show the output, we don't have
mm,
time to practice.
mm, mm.
Yeah, it is
Okay.
like just we are moving ahead, but without any hands-on or practical. So,
Mm,
same, sir, you
yeah.
can do for MIPI also. We can start with that as well. Like, it will be
Uh,
actually good. Just completing theory, it won't be of any use.
But if we want to go for the protocols means, so we need to know some um, basics, right? Verilog, system
Yeah, yeah.
Verilog, UVM. See,
No, so
this is
what I'm
the
saying is,
uh,
you
uh,
complete the
uh,
way you are doing it. Just one day
mm,
you can take theory, one day you can take practical, or maybe
that
theory one
that's
hour
what
and then
see
practical 1 hour.
for the protocols, how we can write the code for without knowing the UVM, all these things. That's what.
Not for protocol, sir. I'm saying
Yeah,
for the
for
combination and
yeah,
sequential circuits.
combinational
Yes.
and sequential I will do anywhere. So after Verilog, I thought that see these are the programs I want to run in front of you. So first time I will explain the theory. So whatever the theory I have explained, see, so this is the code. During reset, Q value will be 0, and then else condition Q value will be D. That is the D
Yes,
flip flop, right?
we will be able to write
Mm,
this, no, sir, instead of
mm,
just looking. If I just look
mm.
at it, I won't understand anything unless and until I try it on my own.
Mm.
That's what I'm
Yes, yes.
telling, sir. Like
Mm,
Verilog in any way you are taking, no, sir, in the
mm,
evening. So
mm,
1 hour you can take, like if you have taught flip flops, no.
mm.
So
Yeah.
then 1 hour, if you have taught flip flops, then 1 hour you can
Mm.
ask us to do, like write the code in Verilog. Otherwise,
Yeah.
just theory of Verilog it won't be useful. No, so we have to practice on our own the programs.
Yeah, yeah. So around I am explaining the codes also in between that, so you can practice that codes in the playground.
In the
Mm.
lectures, sir, in
In
the
the lecture,
evenings.
in between that, I am explaining the codes now. So you can take the same example and then,
Okay.
so then execute in EDA playground. Just check that output is getting that or not. So coming to the system Verilog. Every time, if I said erase, so one example code in front of you only I will execute that. But Verilog, if we complete all the topics, then we will form a design code as well as test bench code. See, one data flow model I have explained. Then one code in Verilog code, based on the data flow model, you will write some design codes and then write test bench. I have explained how to write the test bench, what are the things are there. Okay, this is the test bench explanation. See,
So this is a
uh,
okay, okay.
this is the ports declaration. After that, DUT instantiation. This one is the DUT instantiation. This DUT instantiation purpose, I have explained two types models, either name based instantiation and position based instantiation. Tell me, this one is which type of instantiation?
I
Dot.
have not completed till this, so I don't know what
Okay.
kind of
Yeah, this
instantiation
is the
it is.
name-based instantiation. So dot connection is there means that is the name-based instantiation. So these things I have explained, and then after that we will completely write the one test bench, and then this delays concept is one thing. What type of this delay concept? Hash 10, and then hash 10, hash 10, hash
So
10 is
this
there.
comes under the test bench comes under Verilog only. You are saying?
This is very log test bench only.
Okay, okay.
Huh.
So as of
So
now, you have explained only theory or this test
theory,
bench also,
yeah.
sir?
So I have explained this design part, and then this D flip flop, what it is doing that, and then in this is what type of style I'm writing this code.
Oh, okay,
Huh.
okay. So
This
I think I have missed this in this 2 weeks.
Yeah, yeah. This is the
Okay.
behavioral modeling. Then behavioral modeling style, if always begin, always flip flop, always begin, we are using this means behavioral modeling. Then I'm
Okay.
explaining that behavioral modeling first, and then data flow modeling, and then structural level and switch level. And that some
Okay.
delays concepts are there, and then some always begin where we are utilizing, and then what type of ports. See, this ports representation is one concept, module ports declaration is one concept. Okay, how we represent the ports, input port, here logic is considered. This data type is written means this is the this is a system verilog design. So why is considered the logic means you need to know the difference between the logic and rich, why I'm not utilizing the wire here, or why I'm not utilizing the reg here. Okay, so
Okay.
for that you need to know that continuous assignment and procedural assignment.
Okay, sir. I
uh,
will go through it, sir. Fine.
that's what. So first I will complete the theoretical part, then I will explain the code means, then you can easily understand. Okay, you have explained this one is a
You have
procedural
already
assignment.
explained, no, sir. I think I
ah
have missed it,
yeah,
right?
yeah,
The
yeah, you
theory
missed.
and code.
Yeah, you
Okay.
missed that, so
I will go
you.
through the videos on YouTube
Hmm.
and then I'll sync up with you again in case of
uh,
doubts.
that's why
Anyway, in the
I'm
morning you
taking.
have
Hmm.
started a
Hmm.
new batch, no, sir. So there,
Hmm.
in case you're starting with Verilog, then there I'll attend
Okay,
whatever
okay.
I have missed.
Digitals you don't want, right? Digitals you will go through these videos, right? Or you want to
Yes, sir.
join the digitals one?
Combinational. I will
Ah,
join the for the digital also for the
okay,
combinational part because I missed that encoder decoder, right?
okay. Hmm.
Yeah.
Okay, fine.
Because on Sunday it is better than Sunday. I mean, I
Hmm.
can take rest on Saturday
Hmm.
and Sunday, and I can simply
Hmm.
attend on weekday,
Hmm.
morning
Weekdays.
and evening.
Yeah, yeah, yeah.
That also works. Sir.
Hmm. Anyway, so I will be free to explain with you guys if you are available means, even night also I'm taking the class. But
Yeah, sir. But anyway,
yeah.
there is a
Hmm.
batch going
Hmm.
on, no, sir. So we can
Ah,
attend in that itself. No worries.
hmm.
Like
Okay.
instead of taking separately, hours
Hmm.
time
Hmm.
also will be saved, no, sir. In the
Yeah,
morning
yeah.
anyway, I am anyway
Hmm.
free. There
Hmm.
is a
Hmm.
new batch also, so that's why I was
Okay.
like, I'll attend there only.
Definitely. If we then my
Whatever
thought,
at least I have missed.
my speaking also less at that time, so I don't want to take any extra classes like this, right?
Yes, yes,
uh,
yes.
I think two more classes are required to complete this sequential circuits, because counters are there and finite state machines are there. For counters, one class is required, and finite state machines, one class is required. Okay.
Okay,
Then
sir.
next week I will complete anyway.
Fine, sir. Okay.
Banu is there. Why so silent today? Okay, fine. See you.
Yeah,
See you
yeah.
guys. Hmm.
Yes. All right, sir. Yeah. Thank
Tomorrow
you.
evening we will meet.
Yes, yes. Thank you, sir.
Thank